All right, so as Josh, can you hear me, Richard? Good. As Josh mentioned last month, there's a new registry module in Elixir 1.4. Just a caveat, I haven't actually used it, so I've just been looking at docs and sort of reading up on it. This is a bit of a just an exploration for myself as well. So what is a registry? Straight from the docs, it's a local, decentralized and scalable key value process storage. Bit of a mouthful, so I'll try and demonstrate in this talk where you might use a registry. There's a couple of usages for the Elixir registry. Anyone who's sort of looked at some of the Elixir learning books like Programming Elixir or I think Elixir in Action, you get to a registry reasonably early on, because as in Elixir you tend to be creating hundreds or thousands or tens of thousands of processes, and you need to keep track of these processes. And a registry is generally the way that you can do that. Processes need to be able to talk to one another, and you need to work out which process is doing which thing and how you can talk to it. So we send messages to processes, and that's generally via a PID. So when you create a process or a GenServer or a Gen event or a agent, you'll be given back a PID, and that's something that you can then say, send this message to this PID to do some sort of action. So, but PIDs and registry is a module that can help us keep track of these processes. That's the main thing I'm going to talk about this evening. It provides some facilities that we can use to implement a PubSub system. So we'll touch on that more towards the end. So I'll just talk briefly about processes, process registration and PIDs. So as I said, Elixir processes are tracked by a PID, which is a process identifier. So when you go and spawn a new process in IX, you'll get this thing back which looks like this is a PID, and it'll have some triplet number. That generally means the first number there is the node identifier. So usually if you're working locally, it'll be 0, that's your local node. If you're working concurrently with a whole bunch of nodes, it'll have some other number. And the second number is sort of the process. The second and third number are a representation of that process within that particular node, and there's something I couldn't really understand, but seems a bit historical about process numbers in the local node sometimes wrapping around, and that's when the third number gets into play. But if anyone with a bit more Erlang knowledge can speak to that, I'm happy to be corrected. So you can refer to these PIDs, but sort of passing them around is a bit, they don't really tell you much about what your object is, and you've got to have all these strange PIDs that you're passing around, and there's some other problems with them in that they can change. So the registry provides functionality to map from an arbitrary sort of key or value that you provide to a process. That should say to a process, actually, it's not to a PID, it's to a process. So you can then map from your business domain to a process. So instead of having to say, oh, this, for instance, student ID is represented by this PID, you can just refer to that process using the registry by a student ID or an account ID. So it sort of it's nice to have that rather than having to do this sort of translation in your head. So if you're just so I'm just going to talk about using the registry with a GenServer. So typically when you're I've just called this a plain GenServer. All we're doing is we're starting a link to a GenServer. So we've got the start link. This is the interface. We call start link on this student progress GenServer. We've got some initial state there, which is 0. And this is just going to return that PID that we talked about. And then and it's got some interface functions here, like set progress. And you can see with set progress, we pass that PID back in, which then tells this GenServer, this is the PID that I'm referring to, and this is the progress I want to set. And you can see that that is then translated into this, that should probably be could be a call or a cast. Anyway, that's used by this GenServer function to find that PID and then to call this callback that gets passed in, and I've left out the callback implementations because that's a whole nother talk. and that will call the set progress or the handle cast method with it responds to that map of set progress and progress. So here we've got this PID, and every time we want to call that particular GenServer instance, we have to keep this PID around. So you can see when I start this student progress, I'm getting this tuple back with OK, so the call succeeded, and this is the PID, so this is the PID I was talking about. And then if we want to set progress, we have to pass this PID in, we set it as 2, we get OK. And if we want to get progress, we have to pass this PID around as well. So you have this whole thing. If you're creating hundreds of these things, you can end up having these lots and lots of these PIDs, and there are various ways that you can write your own registries. And as I said before, there's lots of documentation about how you can write registries, and you'll probably have a registry will have a map in it. It'll map something like these IDs to processes. But then you've got a whole bunch, you're sort of doing that yourself. So you're writing all this code that if you use a registry in Elixir now, you don't have to write that code. It comes along with 1.4. So the problem with PIDs is they're sort of transient, and especially, so Elixir's sort of let it fail mentality, or Erlang's let it fail, means that PIDs can and will change. So if you've got a supervisor and you're creating processes, and they may be named, or they may be you may be creating a whole lot of processes, and if they get restarted, then the underlying PID, the process might have the same name, but the underlying PID has changed. So the new process will have a different PID. So you can't rely on PIDs always being the same for the same named GenServer. So there are solutions to this. So there's one of the things we can do is we can name our processes. So this is another thing we'll look at with GenServers. We saw before we can pass in a start link and we just get a PID back. In this case, the third argument here that we're using is one of the options. You can pass in a name to a GenServer. So you can see we can pass in any name there. We can't pass in any name. There are some caveats, but basically you're giving this GenServer a name, and then you can just refer to the GenServer as the name, but there's restrictions on what that name can be. So we can't just give it arbitrary integers or arbitrary account IDs or anything like that, because names have there's only a certain number of types that names can be. It can be an atom, so we could make up a whole lot of atoms. You could make up an atom, student 1, you can make another atom, student 2, and you can keep making atoms and assigning them to GenServers. But the problem with that is atoms aren't garbage collected within Erlang, and you'll eventually exhaust your space of your memory through non-collected atoms. You can also pass in a global and a term is pretty much an arbitrary Elixir value. I'm not going to talk at all about global names, because they're talking about global means you're in a concurrent environment across multiple nodes, and that's once again a topic for a whole nother talk. But what I'm going to talk about is this via tuple. So basically you can name a process using a mechanism that supports this form. So registry supports using via through this tuple. So you pass in via registry, the name of which is the module that is, so this is saying this is a via tuple. Registry is the name of the actual Elixir registry module, what the whole talk is about. And this registry and key, so registry is the specific registry instance that we're talking about, and the key is the value that you want to refer to this process by. So probably some code might be better than me banging on. So typically, as with most processes or most applications, we want our registry to be supervised. So you can see down there, we've got our application. We're starting our application and we're adding the registry as a child, a worker child. You can see that I'm passing the unique option. You can pass a unique, or I think it's a duplicate option for your registry, and then I'm giving it a name. So in this case, I'm just calling, this is my student registry. It's an instance of registry, and it's only going to accept, its mode is unique, so it'll only accept one process per key. So we've started up our application. How do we go about using it? So in this case, you can see it's pretty much the same. It's a student progress, it's a GenServer, we've got our start link. But in this case, we're passing in, we do a lot with students at Blake, so we're passing in a student ID. So we're using the name, but we're getting the name from this via tuple function. So you can see there's a function here, via tuple. I'm passing in the student ID, and if you look down here, that via tuple function passes the, yes, studnet, my most, the typo I make all the time. So you can see that that is going into this function via tuple, and I'm returning this tuple, which is via the registry, which is the registry model, and then I'm saying use the student registry and the account ID. So the account ID then becomes the thing that I have associated, this process can be referenced by. And then, sorry, it should be student ID. Yeah, copy and paste job. Yeah, that should be student ID as well, Richard. Thank you, well picked up. Feel free to point out any more of those. So you can see down here, and where this gets nice now is that when you're using the interface, you can see I've got a set progress here. I just pass in the student ID, so I don't need to keep this extra PID around. I can get the student ID from wherever it is in that other object, out of the database, however I want to grab that. I don't have to persist that anywhere, and I can set my progress. So I'll just look at that. So here's how we so this is how we can use it when we start this instance. When we create a GenServer instance, we pass in the student ID, and you can see that I don't really care about what it's returned. I just care that this ill-formed OK atom indicates that it's succeeded. I can set the progress by the student ID, and I can get the progress by the student ID, which just makes a much nicer API. I think that's a big win in terms of not having to pass PIDs around or having to write your own registry. So that's, in a nutshell, how you can use the registry. The registry can also be used for PubSub, so it has some functionality that can be used to implement a PubSub system. So for those that don't know, PubSub is sort of a pattern whereby message senders are decoupled from the receivers of those messages. So the idea is that you can have some things that are sending messages. So over here on the left, we have a whole bunch of publishers. And over here on the right, we have a whole bunch of subscribers. So these are PubSub, publisher, subscriber. Publishers send messages to a service, and that may have a number of different topics. So they can send messages to various topics. Excuse me. Subscribers can and they can send to more than one message. So any publisher can send a number of messages, and subscribers can likewise subscribe to any number of topics. So in here we've got a couple of subscribers just to one topic, and one subscriber subscribing to two topics. So that decouples these entities. Your publishers don't have to know which subscribers are interested in their messages, and likewise the subscribers know nothing about the publishers, and it's all mediated by this PubSub service. And there's a few different ways you can do this. There's Phoenix has a PubSub system. You can write one yourself, of course, and Registry offers the functionality to do PubSub as well. So typically to have a PubSub system, you'll start the registry in duplicate mode. So we have this and that allows you to associate more than one process with a key. So you can see I've just started a registry. This one's called Registry PubSub Test. From within a process, I'm showing more about the subscription here. Sending something to this to the registry is relatively easy. So you can see from within a process, I am saying for this registry PubSub test against the key hello, register. So this is called within process 1. So you've got to pretend I'm in process 1 here. I'm calling this function. You have to pass some value at the end, and I don't really know why that is, but you can attach a value along with that key. So you have your process under a key and it has a value. And then from in another process you can register against the same key and you could have a different value if you wanted. And basically the way that you then, for this topic, send messages to those subscribers is you use the dispatch function. So there's a dispatch function that says registry dispatch. For this particular registry, under this key, I want to know all the subscribers, and that's the entries. And then you'll just do a comprehension, and it will give you, for each of those, it will give you the PID and this key, which I'm not particularly, whatever this value was, I'm not particularly interested in that, so I just ignore it. And then I can just send a message to it. So I can send that message will just then get sent to all of those subscribers. And that's pretty much a PubSub system in a nutshell. So your publishers will do something like this and say, you obviously put a nice interface around this. They'll just call these different, they can send different messages to different topics, and then they'll be dispatched to each of the subscribers. That's about the nub of the talk. So in closing, I think the registry module is a welcome addition to the Elixir core libraries. It gives you an out-of-box functionality that can be used for both process registration and lookup, a pretty easy PubSub implementation. Previously, third-party or bespoke implementation of these was required, and this is no longer the case. So it's good to see this coming into the core. That's me. I work at Blake. We're always looking for good people to hire that are interested in Elixir too. So if you're interested, I'll be at the Red Oak and come and talk to me. Thank you.